Hey everybody, thanks for tuning in. Ronnie here. In the last episode, or in the last video, we had the networking working, but the camera was misbehaving. Okay. Um, the multi-purpose camera rig that we're using, it is looking for the player, okay, and looking for the player by tag, okay. That's great, but um, it's what it was doing is attaching itself to the first game object that is tagged as player, and that's not really what I want to do. So um, I have given this a lot of thought. Okay. Step one, or concern one was uh, uh, giving the making a change to the multi-purpose camera rig. Okay. To do that would require enabling networking capabilities, and because everything else works properly. Okay. Um, so doing that would require enabling uh, the networking capabilities within the camera rig, and I don't really want the camera networked. The second option is making a change to the player. Um, this I seriously considered. Okay, in fact, as I was kind of going through options and testing, I actually made an extra tag called Other Player, which you might want to go ahead and make. I'm leaving it there because I'm going to use that later. But so that the player would be tagged dynamically at runtime, which still works, okay? But I decided against that as well. Okay, we're going to be doing some custom coding on Chan to set up animations and such. As it stands, we're going to be making some pretty large alterations to our scripts. And so what I decided to do is get rid of the multi-purpose camera altogether. So goodbye. At this point, we are not actually using any of our standard assets. Okay, so we can get rid of the standard assets folder. I'm going to hold off on that for just a moment. But that means we do need a camera. So I'm going to take our main camera and reactivate it. I went ahead and moved the main camera just a little bit behind Chan. Okay, if you've got yours, it's still probably at 000. If you click on it and get your preview, it's going to show you basically not what we're not this picture. Okay, so I just moved it a little bit behind, a little bit above Chan, just for the moment, and I'm going to actually attach the main camera to our player prefab. Once again, this is not a permanent solution. This is a temporary solution. I'm going to give the camera some more functionality later, but for right now, we're just going to attach it to our player prefab and go ahead and apply that. The next thing we want to do is go to our player controller script, and I just made a real, just super simple addition here. I created a public camera variable called player follow cam, and then in start Okay, you can create the awake if you want. We're going to use that later. But in start, I'm asking, is this the local player? If it's not the local player, then we're going to take the player follow cam, call on the game object, and set that game object active as false. And that right there takes care of the entire camera issue. Back in Unity, in your player controller script, you just want to open your player again, grab the main camera, drag it down into the player follow cam, and that is the main camera. Don't forget to hit the apply button, and then you can delete that player. And let's give this a hit save, and then let's go ahead and give it a test. So we'll hit build and run. And hit play. And we are going to host. Okay, so here we have Chan. We're behind her, and the camera is literally following her. It's, like I said, not what we want eventually, but it's a start. And then in the editor, we're going to hit play and call this a client. And there's Chan again. And if we look here, there's the client. This is the server client, and this is the client client. And on here, we can come around and see there's Chan. And movement is independent. It is syncing. I'm going to have to click off here for a second because I want to move this one. And if we bring this back up, there we go. So here we have the basis all done. Okay. We're not getting any errors about multiple audio listeners because we are, if it's not the local player, then it's just deactivating the entire camera, including its audio listeners. So let's go ahead and hit stop. There we go. Now the next thing, I was getting a couple of errors here from our health and magic scripts. Show you real quick just what I did to get rid of those. It's complaining about this line right here, okay, where we're changing the length of our magic bar and health bars. To get rid of that, just right here at the very beginning of the update, it's update magic bar, and then over here on the side is update health bar. Just add these lines, okay? If magic bar is equal to null, then return. That's simple. Because even though we are declaring a magic bar, okay, and it's an image, we're not assigning it, okay? It's not the same thing as our current MP and max MP. Those those automatically get assigned a value of 0 when they're declared. Okay, and then those numbers can be changed programmatically. The same thing with health. Okay, if the health bar is equal to null, return. Okay, and that will. It doesn't do anything really. Okay, it just protects from if the health bar is or magic bar are not actually instantiated. One last thing that I want to do, and this is over here on our canvas. I'm going to come out. I'm going to go back into 2D mode. And just right here, and I noticed this when with these smaller window. I did on the health bar. I did not. Okay. What we want to do is on our health bar container. Oh, we did. What did I do wrong? Okay, on the health bar, I'm just gonna do the same thing. I'm just gonna give the I'm gonna set the anchor points, and I'm gonna do the same thing on the magic bar and set its anchor points, so that it fits, it stays within the confines of the container. All right, so Control S and go back out of 2D mode. We'll come down here so we can get back to our thing, and let's go ahead and hit play. Hit the host, and there we go. Okay, so, but that's full screen. Let's go ahead and do a build and run. That way we can make sure it's working in a not 16 by 9 or in a different aspect ratio. Since this is 4 by 3. And there we go. Okay, so now they're fitting, okay, which they weren't doing earlier. That's good. So that takes care of that part. Now the next thing I want to do, and we're going right back into our character controller here. We're going to be making some changes. Not necessarily changes. It's not really what I want to say. Well, no, we're going to make some changes. Okay. Kind of make this a little bit more friendly. Okay, that's the words we'll work on. So the first thing I'm going to do is there are some components that are absolutely on our player. Okay, and so we're going to make it a requirement that they are there. Okay, the first one, and there's going to be 3. Okay, we're going to say require component type of, and the first one is going to be the animator. Because we are going to be implementing animation. So I want the to make sure that the animator is there. Okay, if it's not, then it will throw an error and let us know. We're going to require a component. Whoops. Type of, and this is going to be a capsule collider. Once again, and this is for the collider is a requirement because we are using a rigid body on Chan. Okay, we're not using it. The fact is, all of this code right here works just fine without a rigid body. Okay, but I want to use the rigid body. So, and Chan comes with a rigid body on her. Okay, we could disable it or remove it, and it would be fine. Okay, that code still works, but it would require some more coding because then we'd have to enact things like gravity programmatically. So the third thing, I said I'm going to do 3. We're going to require component, type of, and this one you got is the rigid body. All right. The rigid body is a requirement because we are going to change the movement to a rigid body based movement system. We went ahead and set up the player follow cam. We're going to go ahead and add a few more variables. Okay. So we're going to create a public float, and we're going to call this anim speed, and we're going to initialize it to 1.5 f. A public float look smoother, and once again we'll initialize it to 3.0 f, and a public float use curves, and I'm sorry, I'm losing it. I said public float. No, it's public bool use curves, and we'll initialize this to true. Okay. Now, when you're declaring Boolean values, if you don't initialize it, it is assumed to be false. Okay. Now you can initialize it to false, or you can just declare it. Okay. They're both the same thing. If you want it initialized to true, then you have to absolutely use the initialization. Okay, so now we are going to create a public float, and this is going to be use curves height. And we will set that to 0.5 f. Some speed float variables. So a public float forward speed, and that is going to be 7.0 f. We're differentiating forward speed and backward speed, which is the next one, because Chan has separate animations for forward and backward. So I like that. So our public float backward speed, and we're going to set this to 2.0f. So she backs up slower than she moves forward. And we need a rotation speed, so a public float rotate speed, and we will set that to 2.0f as well. And right here in this group, we'll give it also a jump force. Which we'll call jump power. And set that to 3.0f. And then we need just a few private floats, or a few private variables. So a private capsule collider, which we will call call. A private, not prop, a private rigid body, which we will call RB. A private vector 3, which we will call velocity. A private float, which we will call original. We're going to shorten this, but original collider height. And private vector 3, which we will call original vector collider center. So and then we do need to reference our animator. So a private animator, which we will call anim, and a private animator state info, which we will call current base state. And that is that. Let's go ahead and declare some states. So these are going to be static. Okay, they just are. Okay, they're not going to be variables that we change. Okay, but they are going to be states. So we're going to start with a static integer, which we will call idle state, and that will be equal to animator dot string to hash, and we will pass it the string base layer dot idle, and it has to be spelled exact. And to save a little typing, I'm just going to copy, and we're going to do 4 states. So there, there, and there. And the second state is going to be locomotion state. And this is going to be base layer dot locomotion. LOCOMOTION. The next state is going to be our jump state. And this will be base layer dot jump. And our 4th state will be rest state. And this will be base layer dot rest. Where's all this coming from? Well, that's all coming from the animator. Okay, we have our player, and we have the controller is Unity Chan Locomotions, and there are various bits and pieces here. All right, let's just move this down here so that we can see. So we've got idle locomotion, which is our walk forward, our walk back, our rest state, and our jump state. Really simple. Back in Visual Studio, in our awake function, we're going to go ahead and assign some of our private variables. So our anim equals get component, animator, our collider is equal to get component, collider. Actually, let's make it capsule collider. Thank you. Just to be on the safe side, our RB is equal to get component, and that's going to be rigid body. Our ORG call height is equal to our collider dot height, and our ORG vector call center is equal to COL dot center. Easy peasy. Now, we originally set our movement script, or the part that moves our character in update, and that's fine, okay, but I'm going to go ahead and comment that out because well, I'm going to uncomment this part, because if I do use the update, whoops, uncomment, okay, If I do use the update, I do want to make sure that I am updating on local player. Okay, but since we are using rigid body physics, we're going to do our updating in fixed update. So void fixed update, and I used vars when I did this before because we were using different things. Okay, it was all coming back as floats. This time I'm going to go ahead and just stick with the floats. So float h equals input dot get axis horizontal and float v, whoops, little v equals input dot get axis, and this will be vertical. Now, this is where the magic happens as far as animation goes. Okay, we're going to set the anim dot set float, and if we go back and look at the animator, and click on parameters, we have several parameters: speed, direction, jump, rest, jump height, gravity control. Okay, so we're going to set some of these right here. Okay, the first thing we're going to do is set the speed, which is always a string, and we're going to give that the value of v, which we just got off of here. Of course, if the vertical axis is not being used, that's fine. Okay, it just returns a value of 0. Otherwise, it'll be somewhere between -1 and 1. And let's also set the direction. So anim dot set float, and that's going to be direction, and we're going to set that to h. And anim dot speed is equal to our anim speed. Our current base state is equal to anim dot get current animator state info 0. And finally, this does cover forwards and backwards and sideways, every way that we want to go. We haven't put in a jump yet. That will be coming, but we do want to make sure that even if we're not jumping, okay, if we go up a hill and then come back down. We want to make sure that we're coming back down the hill. So let's make sure that the gravity is in place. So RB dot use gravity and just make sure we set that to true because that is a bool. Oh, equals true. Okay, so now at this point we have received some input, okay, or not, okay, but our horizontal and vertical variables here are populated, okay, with a number between, a floating point number between -1 and 1, and it could be 0. So what we want to do is determine if we are moving forward or backwards, okay? Because remember, we want to move forward faster than we are able to move backwards. So if v is greater than or equal to 0.1, well, let's just make it greater than. So if it's greater than 0.1, then we're going to set our velocity times equal to forward speed. And then else if v is less than negative 0.1, then we will set our velocity times equal to our backward speed. And that's how we make the different velocities for moving forward or backwards. So that's almost all of our movement. We do need to, well, we haven't assigned movement, but we've got forward, backwards, left, right, turn, everything's set there. We do need a jump, and we've got gravity in place. So let's go ahead and do jump real quick. So if input dot get button, let's make it get button down, and that button will be jump. Then, which equates to the space key on the keyboard. Then we are going to check our state, okay? Make sure that we are not already jumping. So if current base state dot name hash is equal to loco state, okay, so we are moving, and if, and we want to do the opposite here, okay, anim dot is in transition 0. So if we are not in transition, okay, between states, then we're going to say RB dot add force, and we're going to give that a vector. So vector 3 dot up, and we are going to multiply that by our jump power. And when we're adding force, we need to give it a force mode, so it's going to be force mode dot velocity change. And then we want to, there's the character comes with wonderful jump animations. The hair bounces and all kinds of cool stuff. So let's go ahead and make sure we activate that animation. Anim dot set bool, and this is going to be for jump, and we will set this to true. Okay, so that takes care of jumping. Okay, it actually forces the jump, causes the jump, okay, and sets the animation to true. So the next thing we're going to do is worry about the actual movement now. Okay, so let's start with transform.local position, and we're going to plus equals velocity times time dot fixed. We're in fixed update, so we're going to use fixed delta time. And for rotation, we're going to do transform dot rotate, and we are going to pass it in 0, h times our rotation speed. And 0. So right now, at this point, it would just work, okay? There's a couple of other things that I want to do here real quick. This is going to be a fairly lengthy class when we're all done, but because we're taking all of these states into account. But the next thing we're going to do is an if statement. So if, and we're going to grab the current base state and name hash it. So dot name hash. And if that's equal to jump state, then if we have use curves turned on, which we should, then we're going to call another function, okay, which we haven't created yet, but we're going to call it reset collider. And let's go ahead and just create that. We'll do it the fast way, and Control plus, boom, and reset collider. Whoops. Control S, thank you, and reset colliders right here. If we try to use it, then we'll get an error, but that's good. That reminds us to make sure that we have used it. You know what? That's where I messed up. Not jump state. We want loco state. Okay. Because here I'm going to else if and once again we're going to get the current base state, name hash it, and say equal to jump state. And this is where we're going to use our jump state. I'm going to do something with the camera, okay, the player follow cam. In probably the next video, but I'm not going to use it right now. But I want to go ahead and put it in here because this is really the place to go, okay? We're going to be using events as well. So I'm going to say player follow cam dot send message, and the message that we're going to send is set camera position jump view. Capitalize that P. Once again, it's not really going to do anything yet, and so I'm going to comment that out because we haven't set the event in the camera itself yet, but that's fine. What I do want to do is check if the animator is in transition. So if not anim dot is in transition, and that gets past a value of 0. And in here, and we're going to check if we're using curves. If use curves, and here we work with our jump height and gravity. So float jump height is equal to anim dot get float, and that float is called jump height. And we're going to set gravity, so that's a float as well. Float gravity control is equal to anim dot get float, and this one is gravity control. Remember, these have to be spelled exactly this way. Okay. Now, we want to use gravity we don't want to use gravity if the gravity control comes back with a number bigger than 0. So let's go ahead and do an if statement. If gravity control is greater than 0, then RB dot use gravity is equal to false. So just while we are in the act of jumping, we're turning off gravity. Okay, and you'll see how that works in a moment. The next thing we need to do is look for is set up a ray. Okay, because we're going to do a ray cast. This is still in the use curves, so we're going to create a ray, R-A-Y, and we'll call it ray, and this will equal a new ray. And we will set the ray at transform dot position. Add to that vector 3 dot up, and cast it at negative vector 3 dot up. And we need to keep track of our raycast hits. So raycast hit, which we will call hit. We'll call it hit info for this one. And that just equals a new raycast hit. You know, we don't need to complicate this. We'll just call it hit. So if physics dot raycast, and we're going to pass in the ray and output the hit. There we go. And we're going to check the distance. So if our hit dot distance is greater than our use curve's height, then our collider height will be equal to our original collider height minus our jump height. And that's because she shrinks, not shrinks. She kind of crouches as she's jumping. You'll see. we do need to adjust the center, so float a dj center y will be equal to our original vector collider center dot y plus our jump height. And now we will actually set the center. So collider dot center equals a new vector 3 0 comma adjust center y comma 0. All right, my phone just went off. I need to check that. And now if the hit distance is greater than the used curve's height. Now if it's not, let's say else, then we're going to reset the collider. And let's see here. Outside of our curves, make sure we're in the right one, curves, but still inside of the not in transition. Okay. We are going to say at this point we have landed, and so nm dot set bool for our jump, and that's going to be false. Sweet. We are getting closer, my friends. I know this is turning into a long one. So back to we got our local state, we got our jump state, and here we are going to set an else if to cover our idle state. So we will go current base state dot name hash is equal to our idle state. Once again, we're going to check and see if we're using curves. So if use curves, and if we are, we're just going to reset the collider. And then we're going to check and see if we are getting a button to jump. So if input dot get button down jump, oops, there we go. And if we are, Then we want to set our rest bool, nm.set bool rest, and that will be true. And that right there takes care of our idle state. Nowhere near as complicated as jump state. Let me see here. So we've got loco state, jump state, idle state, and that leaves our rest state. So else if our current base state, name hash is equal to our rest state. And here it's really simple. We do not have to check and see if we're jumping. We're just going to say if we are not in transition. So not nm dot is in transition 0. Then we're going to set our rest state to false. So nm dot set bool rest, comma, false. And that fixes that. We have one last thing that we just need to do, and that's resetting our collider. That's 2 real quick lines. We're going to set our height to equal our original collider height. And set our center to be our original vector collider center. So right there, that should that's what I know. It's been a while here. It's a pretty long bit of code, but this should right here take care of everything, so that now our player Chan will be able to run, turn, jump, and take care of everything that she needs to. So we don't need to do a client and server. We can just go ahead and do just one for the test. Hit LAN host and okay. She runs, she turns, and for some reason I forgot to put in making her move. Okay. I haven't put in the making her move. I'll get that in, well, we'll just go ahead and take care of that right now. Where did I mess this up at? I just need to go with position. Let's give that a shot. Nope, that's not working either. Okay. I'm going to look into this and we'll fix that in the next video. If you have any questions, please throw them in the comments below. If you liked the video, give it a thumbs up and don't forget to hit that subscribe button. I will see you in the next video.